All right, so broadcasting, it says, live, it says, and I can see it on YouTube. Hello, everybody. Good afternoon. I'm trying a new setup and I don't actually have my monitor, like my audio monitor. So let me know if you can't hear me. That would be helpful. For which tab am I in? This tab. Okay. So I can see my mouse now. So today we're going to do something a little bit different. We are not going to be doing live coding. We're going to be doing live code reviews. So if you haven't done code reviews before, actually, I'm paranoid now. I just want to double check that you guys can hear me. Oh, Elliot says hi. Hi, Elliot. Hopefully that means you can hear me good. So if you're not familiar with code reviews, they are something that's really commonly done in the thing that is a different field, software engineering. Wowzers. They're really commonly done in software engineering. Elliot says, yes, you're coming in. Excellent. Thank you. I was worried. And the purpose is to have a human look at somebody's code and basically figure out if there are any problems with it. So I'm not going to be doing things like, oh, you violated PEP 8, your lines are too long. Those are things that a linter can fix. I'm going to be checking things like the logic of code. So did you say that you had a log normal distribution, but you actually had a different distribution, uniform distribution, or things like that. So checking the logic, checking the math, seeing if names are misleading or if a variable name says it's one thing, but it's actually something else. And I asked for some volunteers on Twitter, and some people very bravely volunteered. And the first one that we're going to be looking at is K.A. Smith 11, who I think is Kendall Smith. I always do that. Yeah, Kendall Smith. And he did a project, I'm assuming I'm guessing, on clustering NBA players into 5 categories. So let's take a peek at the R Markdown. I haven't looked at these previously. I haven't looked at this code previously, so I'm starting with it from scratch. And if you're not familiar with R Markdown, it's very similar to Jupyter Notebooks. You have text, you have code. This isn't rendered, unfortunately, which is a little bit of a pain, but should be good. So let's check it out. The clustering analysis uses the ball-R package to access the per-game statistics of players in the 2019 season from, it goes off of here. So ball-R, I'm assuming, is a data package that's pretty common in, you can't see my mouse. Okay, that's pretty common in R land to use packages that have just specific data in it. So you may be familiar with the Iris package. Actually, that's a built-in. There's a bunch of like U.S. Census packages that have the data, and they're available on CRAN, which is a package repository on R. So that's not super surprising. The clustering analysis uses the ball-R package to access the per-game statistics of players in the 2019 seasons. That's this year. So this might be useful if you were looking to enter the March Madness competition we have. Is it NAACP or NACCP? I think it's NAACP, National Athletic Association College Programs, whatever. Anyway, so there's a Kaggle contest right now on how good you can guess about basketball. All right, so this is okay. So when this is rendered, you will see the code in the rendered chunks. So we're reading in so we load the library, and then we're using this function to get information on season 2019. Shed says NCAA. Thank you. That's very helpful. you can tell that I'm a deep basketball fan. I actually did do college sports, but I did fencing, so I know much more about the FIE. So here I see that we're reading in the statistics, we're getting the specific season, and I see that we're taking only some columns here. So one thing that I might change here is instead of doing these by the number, do them based on some quality of the data frame. I don't actually know what this data frame looks like, but if you have something like you only want things that have the word point in them, you could try select where. Declare, I think it's in. I'm in incognito mode, so I don't accidentally show secrets because I'm doing things for my work computer. So the select function has a number of functions that you can use that, and this might be a little bit hard to read, let me make it a little bit bigger. So within select, you can use things like starts with, ends with, or contains. So I can say I want all columns that contain the letter A using these functions. Also matches, numeric range, one of, so if you have a specific list and you want things that are one of those lists, or everything. So using this along with the column specification and select is probably going to be a more reproducible way to do this. Because if later on this package is updated and they add a column and it's column 9, you're going to get an additional column you don't expect, and you won't get that last column that you do expect because everything's been bumped over by one. So that's something that I might change there. Jaroslaw says, I drank too much alcohol tonight and I'm not able to understand anything. Well, if you're not an R person, this is R, and the next project I believe will be Python, so that might help. Okay, and then we are doing data preparation. Okay, so we probably don't need, it looks like it's pretty much the same text in, so this would be a markdown cell in a Jupyter notebook, and here it's sort of the text in between code cells that are run. And we probably don't need the same information both in the comments and also in the body of the markdown document. It's just a little bit redundant. You can save yourself a little bit of typing. So I would either move these comments to the outside, or if you actually end up having everything that you want in your comments and you don't want inline images, then you could do this not as an R Markdown script, but rather just as a script, and it'll generate the images. I don't know what else is going to happen down here though. So that might help make it file a little bit shorter, your life a little bit easier. And then we're doing library tidyverse. So my preference is to import all of the libraries together up in the setup cell. That way, if you have version differences between things, it's a little bit easier to deal with them all at once, I think, rather than sort of figuring out that you have problems when you get to that point in the script. So I might move library tidyverse to the top here. And we're taking NBA, which is this object that we've made here. We are replacing all of the NAs. We're scaling, and then we're taking the distribution of that. So this takes our scaling data. Oh, sorry, calculating distance measures. I thought this took a distribution. Let's see. Functions dist. Oh, okay, so it looks like it's pretty overloaded. What about the base R function? That might be more helpful because it looks like it does a lot of different things. Okay, so it's probably going to be in one of these R core things that we actually are interested in. Sorry, that's another project we'll look at once we're done with this. Okay, and so it's scaling within each column, it looks like. Filtering out players who played less than 41 games. So this thing that it says that it's doing in the comment, it looks like it's not actually doing. So we have this replacing all of the NA values, and then we have the scaling, and then we have the calculating the distance measures. We'll come back tomorrow. That sounds like a good idea. It might be a little bit easier to follow then for you. These distance measures. Okay, so here we have a mismatch, and I don't know if maybe Kendall decided he didn't want to do that filtering, or he wrote the comment and then forgot to write the code for it. So there's a mismatch there that we probably want to correct. The following runs with a k between 1 and 30. It then saves the sum of squares for each model. The goal of this is to determine the optimal number of clusters that we will use to describe the data. Sorry, I really wish GitHub showed our Markdown documents as rendered. It doesn't support the R kernel for notebooks either. Actually, I do Jupyter Notebooks. I don't think it supports Jupyter Notebooks at all rendered. I know there was an update recently, but I don't remember what it was. If you guys know off the top of your head, feel free to tell me in the comments. I don't want to go off on a Google tangent right now. Okay. Map double. Okay. Tote with ins. Okay, I'm not entirely sure what this variable name is indicating, and I also see that this variable name has an underscore and this variable name has a period. And this is something that a linter would catch, but I'm just noticing it. Elliot says GitHub does support Jupyter Notebooks for Python. Okay, so it's just R that's unloved. The R community is smaller than the Jupyter community, not the Jupyter community. I mean, the Jupyter community, yes, but also the Python community. So I get it. Okay, so this is. Oh, I see. Okay, so this is within. So this is a variable name generated by the model. AI says, don't understand R. For future code reviews, I wrote StyleGAN for portrait art in Colab. It will load in GitHub as well. Feel free to send me a link on Twitter. Some of the other projects that we do are going to be Python as well. Shed says, can the R Markdown be imported into Kaggle kernels? It can. So you can create and run R Markdown documents as scripts, so not as notebooks. They don't follow the Jupyter notebook. But there's a lot of beautiful, beautiful kernels that are done in R Markdown that are just stunning. Jonathan Boucher, in particular, has done some just jaw-droppingly gorgeous kernels in R Markdown. So yeah, we do support it. And Ryan says, GitHub does, but a lot of others don't. At work, we use code commit, and it's the most frustrating thing not to be able to actually see the diffs. That does sound extremely frustrating. Elliot says, who? I don't know. Oh, Boucher. Let's see. Ooh. Oh, okay, it's gone. I've lost my my thing. Let's see, Boucher. Yeah. In users. I'm assuming it's Boucher, and he's done some really gorgeous R kernels. Yeah, I figured it out, Elliot. That we can look at. And he hasn't been as active since he got a job, but he's just done some really fantastic work in R Markdown. Like, look at that. That's so pretty, you guys. That's so nice. That's very good looking. Anyway, it's very, I enjoy his work. All right. sorry, I was talking about R and rendering. So it looks like this variable name is the sum of squares within each model. It's not entirely, so I haven't worked with just the Kmeans object a lot. It's not entirely clear to me that that is what tote withins is doing. So let's look into that really quickly. Kmeans R. Just make sure that that is doing what it think it do. Blah, 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 blah. S3 method for class Kmeans. Can I make this a little bit bigger? Can I learn more about the method? R Kmeans object. Oh, sorry, class. Oh no, it's telling me about classes in the how to do Kmeans with multiple classes. That's not very helpful. All right, well, I'm gonna assume that they're right about this. I'm not actually sure. And then we create a data frame for the sum of squares of each Kmeans model. So K 1 through 30, and then the sum of squares. And then we are plotting the sum of squares for each level of K. So I think these could actually probably be done within, so these could probably be done within the same chunk rather than putting it into two chunks. Again, just like to save time, make it a little bit tighter. But it doesn't look wrong to me. Okay, so we've got, this might throw an error. No, because you've got a second column. So if you want to convert a vector into a data frame, data underscore frame, so a tibble rather than the base R data frame, which has some nice properties, among which is that it doesn't have row names, which means it's a little bit more memory efficient. So if you want to convert a vector, and I think this is a vector, given the way that it's being plotted, then I think it is in table, I think is the particular function you're supposed to use in table. And then I think it's names equals null is the preferred syntax for that. And that's changed relatively recently. It might not actually be in table. Let me search that. R vector to tibble. 2015, so that's going to be out of date. And this has changed relatively recent, so it's not in frame, that's what it's called. So it's not like a big problem if you don't do it this way, it's just a little bit more efficient and is sort of the preferred syntax right now. So if you want to be like R-full, which is my personal way of saying like the R version of Pythonic, this is a good alternative. And from there, you could add your second blah, blah, blah. So instead of having this thing here, actually, because it's 1 through 30, you could just have make names not null, and it would automatically give you 1 through 30 as row names, because row names are by default numeric. So you could get rid of this chunk and make that all one section, if that makes sense. And so that would look like I'm trying to think if there's a way that I can quickly type some code. It would look like, and I don't think there's any way I can show you another thing right here. So it would look like, let's see, elbow.mba in frame model with an S, that one, and then if you leave out the names equals null argument, then you will get, I believe it'll actually probably be n rather than k, that's 0 through 30, because this is a vector of length 30. So just a little extra step you can get away with. And one reason why you might want to do it that way is to avoid making an object that is a vector and then later creating a different object that's a data frame. It's just a little tiny bit more memory efficient. Okay, so once you do that, you plot the sum of squares. So we're looking for the elbow here, which is, I'm assuming, why it's called elbow.nba of the plot. So we can pick a good K, very standard. We're doing a line, and we have breaks from 1 to 30 on the x-axis, so we can see a little bit more clearly. This could be a line. It could also be, I personally find it a little bit easier to figure out which one it is if there's a point. There's nothing wrong with a line. That's just my personal preferences to plot points here. Yeah, no, lines are fine. That's just like an aesthetic thing. And then run a Kmeans model and keep the silhouette widths for each level of K. Silhouette width measures how well the clustered objects are. How well clustered the objects are. Values range from -to 1, 1 to 1, with higher values indicating a better fit. Interesting. I am not familiar with silhouette fit. Okay. Using the PAM function here, which I'm not familiar with, where K is our where is K defined? So here it's defined within this function, and then we are so we're defining a custom function, and then we're feeding it 1 through 3. So this would be sort of like a lambda in Python. And here, okay, so we're doing the same thing, but we're doing 2 through 30 rather than 1 through 30, which we've been doing previously. So I'm not entirely sure why we aren't doing 1. And it looks like we've switched away from doing 1 permanently from this point on. So I would say why that is, or either do only 1 through 30 or only 2 through 30. And again, I'm not super familiar with silhouette widths. And it looks like we're doing the average width of the silhouette. So let's look at that really quick. Silhouette width. Kmeans. So here's something from scikit-learn, which is a Python package. So we'll not have like example code. And it looks like it's extremely tiny is what it looks like. Get bigger. Even bigger. That's as big as they get. Okay. I'm trying to read this. It's really tiny and it's very pixelated. And if it's pixelated for me, I know that that's going to be nigh unreadable for you. Okay, so here we have, so down here it says the silhouette coefficient values. And here it says cluster label. So each little chunk is a specific silhouette. And I don't know what we're looking for. And then over here we have points, which are labeled and color-coded. So here is one cluster, here's another cluster, here's the silhouette for this cluster, here's the silhouette for this cluster. So I'm guessing as you add additional points, you want the silhouette to be smaller because that means it's tighter around your cluster. Yeah. So this one is too big because we can see that as we add more points, it becomes smaller than our apparently arbitrary boundary that we're looking at, which is different for each one. So this must be something calculated. This boundary must be calculated based on some quality of the data set. And then looking here, if I'm interpreting these graphs correctly, this one looks pretty good because all of them are over the line. And it looks like the total mass of things that are over the line, which again, I don't know how that is calculated, looks to be fairly high relatively. Whereas this one, so there's 1, 2 clusters that should probably be different clusters that here are clustered together. And this silhouette looks like it's all under this line. And over here, where we have something that should probably be 1 cluster, examining it visually, that's split into 2 clusters, both of those clusters are under here. So it looks like the thing that we're guarding against here is clusters that are too small. Because if you have clusters that are very small, the points are going to be much closer to each other on average, but we'll also have something about silhouettes, I guess. Interesting. Like I said, I'm not super familiar with this particular method of evaluating k-means. And then so here I would do the same thing that I mentioned before. So to enumerate that, frame this this vector and then add the k. Ryan said, I was interviewing a guy who used silhouette score in some code. I asked him what it was and he didn't have an explanation. I still don't know what it is. Yeah, so plot the silhouette widths for each level of k. So that's what we are seeing here. Oh, that's the average. Okay, so this is the average silhouette score, which I don't know how it's calculated. Blah, blah, blah. Silhouette analysis can be used to study the separation distance between the resulting clusters. The silhouette plot displays a measure. Okay, I saw a little Kaggle K flash up there, but it looks like we're back now. I don't know what that is. It happened last time too. Silhouette analysis, blah, blah, blah. The silhouette plot displays a measure of how close each point in one cluster is to points in the neighboring cluster, and thus provides a way to assess parameters like number of clusters visually. Okay, so it's sort of a, blah, 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 blah. Oh, Jesus, what's the thing I'm thinking of? It's like repulsion, but that's not what it's called. Oh, it's like the opposite of center of gravity. Oh my gosh, we use this for vowels all the time. What is it called? Awayness from other things. Let's call it that. Silhouette coefficients, as these values are referred to as near +1, indicate that the sample is far from neighboring clusters. A value of 0 indicates that the sample is on or very close to the decision boundary between 2 neighboring clusters, and negative values indicate that these samples might have been assigned to the wrong cluster. Oh, so a negative value would be it's inside the silhouette of a different cluster. Okay, so it's sort of a measure of separation. I learned something. I learn something every day. There's so much I don't know. There's so much everybody doesn't know. But it's nice, right? It means there's just lots of stuff to keep on learning. Okay, so and then we plot the silhouette widths for each level of k to see how well on average each player fits in their cluster. So we would want to see we want to see most of the silhouettes to be closer to 1, and we wouldn't want to see any negative numbers here. And the bigger they are, the more distinct our clusters are, is what I'm getting from that. Since these aren't, well, I guess they kind of are, because as you scale k, then the silhouette width also changes. And we're looking at the average silhouette width. I don't think we want the average silhouette width. I think we want a distribution of silhouette widths, because if you have one silhouette that is 1 and then a bunch of other smaller silhouettes that are -1, you'll get a very low average silhouette. But if you have, I don't know, I'm still learning. Ryan says he iterated through the number of possible cluster sizes and found the optimal cluster size was either 4 or 58. There were 58 data points. So if you're optimizing for silhouette, then yes, a cluster size that is the same as the number of clusters as data points will be the one that you have the best luck with. There's definitely something else you can do with Kmeans that I've seen as sort of like a validation technique, and I don't remember what it is. Nope, not in there. Okay. So this is sort of a validation to see how homogeneous your clusters are. And presumably we'd get away from the problem with 5 to 58 by using the sum of squares for within each model and looking at the elbow of that. Okay. And then we're doing a Kmeans model with k equals 5. Presumably we've picked that given our previous examples and analyses of the model size that we looked at. And then create 2 separate data frames, one for assigning the cluster assignment to players and another data frame to analyze the means of each cluster. Okay, so this is going to be giving us player assignment, and this one gives us the mean for each stat by cluster. And I don't know how many stats we're looking at now. So one thing that I am a little bit worried about here is this is since we're looking at, so we're looking at 20 features, and I don't know how big the data set is. So I would want to make sure that we have a pretty big data set to justify having. So if you're going to use a lot of features, then you also want to have a lot of data that's dispersed across your feature space. Otherwise, you might get really good separation based on, one feature, and that just happens by chance. I also didn't see any discussion of scaling. And again, I'm not super familiar with basketball, but I feel like the scale for things like points scored and the scale for things like passes made is probably going to be pretty different. So mean points scored is probably going to be lower than number of passes made, which I'm assuming is a thing you track. Again, I'm extrapolating wildly here. I'm not very informed about basketball. Okay. And then it seems the clusters are measuring tiers of performance, with cluster 4 ranking highly for most categories. So the hypothesis that we have here is that better players, like the clusters are showing sort of like player ability, and they're sort of different levels of ability. I'd be interested to see if there was any relationship with position. I do know that there's positions in basketball, right? Are there positions in basketball? I'm just gonna, like, point guard's a thing, right? Yeah, shooting guard, small forward. Yeah, there's definitely positions in basketball. Jaroslaw says LeBron James is the answer on any question. I think that would be a bad answer to the question how many clusters there are. Okay, and then we have a oh no, I don't like that. So this hurts me on the inside. I do not like leftward assignment in R. So in R, you can assign rightward or leftward. Most languages, you can only assign rightward. I hate this. I hate this to the bottom of my soul. I would do something like either cluster means radar and then assign it that direction, or there's a, if you wanted to call this, if you wanted to assign the thing that you are doing your things here to the same thing as the input, you can use the pipe that. So instead of this pipe that passes it all one direction, this pipe will pass it all one direction, and once all the calculations are done, it will reassign it to whatever you put it in, whatever you put in the beginning. And if you are doing that, then you want to make sure that you are if you're doing that in a notebook, you want to make sure that you are not running that cell twice, because that will give you errors. But if you're using a script, and our markdowns are scripts, then that's a nice little shortcut from Migrator, I'm pretty sure, or the tidyverse generally. Again, I like these up top, and I think we imported I think we imported tidyverse. Yeah, so ggplot2 is in tidyverse, so you don't have to import it separately. And unfortunately, we can't see the beautiful charts, but I believe in my heart that they are beautiful. So those are sort of my thoughts on this. I learned some things about Kmeans, so that was nice. Yeah, and the next step on this project might be to incorporate information about position and see if there's any sort of overlap with the clusters that were done. Oh, can we see? Hey, we can see our figures. So here are the clusters. Yeah, here are the clusters, I'm assuming. So this is cluster 1, cluster 2. That can't be it. No, but this is the only radar plot that we did. Let me look at the other ones. What's that? Okay, so this is finding the elbow. I would say, I actually might say it's closer to here than closer to 5, but I think 5 is perfectly fine. Yeah, I might put it at more like 10-ish. Finding the elbow is not an exact science. And then this is going to be the one that shows us the, oh, sorry. So this is the one that shows us loss. Sorry, square means. Yeah, I'd say 5 is right around the elbow. I might even go down to like 8, but that might decrease the amount of explainability of your model. And okay, so this one is the silhouettes. Nope, I just clicked on that one. The bottom one is the silhouettes. All right, and we want silhouette widths to be closer to 1. Oh, I see. So the silhouette widths, we want to be higher, and then the other one, the squared loss, maybe? I forget. We want to be lower, so 5 was sort of a value that was looking at both of those. So one thing that I might do that would be helpful since you're comparing both of these is to look at both plots on the same, both charts on the same plot. And because the, well, actually, I don't know that is the case. Is this one 0 to 1 as well? Yeah, and you don't even have to do, you might do one side is one legend and the other side is the other legend, but that may make it a little bit easier to visually compare these things and sort of figure out what the optimal cluster size for your particular problem is. And I would, based on this plot, I would label these with your clusters, and I might even make these particular, the outside. So I'm assuming that these are specific features from within the clusters, although I think there's 20 features total based on the data cleaning that was done. So I might make these a little bit more clear. And I'm guessing outer is gooder. So it looks like there's this inner orange cluster, which is low. This raspberry-y colored cluster is a little bit higher and has this FG% as an outlier feature. And then we have this sort of triangular blue cluster, and then this bigger purple cluster, and then finally this green cluster that's very close to the outside, which I'm assuming is good. Yeah, so maybe even a little bit of explanation of some of these things might be helpful for people like me who don't know basketball. Although I don't know why you'd be doing basketball analysis for coworkers who have no background or interest in basketball. Yeah, I think overall it looks really good. I like the amount of comments. I think it was really helpful. I wish we could have seen the beautiful report. Oh, there we go. Oh, it is. Okay, so here it is all pretty and rendered. Yeah, and I would move all of your imports into the first cell. So that's the big thing. Yeah, looks good. All right, now let's move on in the last 20 minutes. So I also got some blah, 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 somebody. I also got tweets. Wow, sorry, I'm getting tired apparently. I also got tweets from Daniel Canueto, maybe. I think on Twitter it has a little Enya in there, so I guess Canueto, possibly. My apologies if I say your name wrong. That's on me. Your name is fine. I'm the bad saying one. So let's look at we did sort of like well, let's start looking at the exploratory analysis. So I believe this study, which I saw on Twitter a while ago, is designed to look at within disciplines the distribution of reported p-values. So if you're not familiar with p-values, they are a measure of how likely you would be to get the statistical results that you did if the population that you were pulling from and the population that you're looking at were actually the same by chance. So it's not a probability. It's not a so it's not the likelihood or anything. It's almost a measure of like how surprised you should be if your underlying, if the population that you're looking at and the population as a whole are the same, more or less. Which populations you look at is going to depend on your specific study design. That's kind of the idea. And so I believe that we got a lot of information from this package. So it's a repository of millions of p-values with additional information such as the year of publication, the PubMed ID, and or a DOI, so digital object identifier of the article or scientific field for whom the article belongs to. So we would, I don't know, maybe we'd expect going into this that reported p-values are going to be, you know, below whatever the threshold is to our for our discipline, and we might expect that they have sort of like a, I don't know, decaying distribution. I don't know. I don't have strong hypotheses about what this would look like in a sort of an ideal world. And for this repository, they created a data set of p-values, which merges the p-values from two different studies. So this one, HEAD 2015, and this one, Chevalier, 2016. And this one was in PLOS, and this one was in JAMA, which I am not familiar with. Oh, okay. Thanks. Sorry about that. It's definitely a medical journal based on the little pop-up we just got. Sorry. Journal of something. What does it stand for? Well, JAMA. Registered trademark. Oh, it must be the Academy of Medical Associates, maybe? Who is AMA? What is AMA? Not helpful. Not helpful. I have no idea who publishes this gosh darn journal because they're just recursioning everything. American Medical Association, probably, right? Probably that. Ryan says, Journal of the American Medical Association. Thank you. So it's a medical journal. And then we have PLOS One, which is the Public Library of Science, Biology. I will say, as somebody who has a depth of knowledge in a field, and sometimes PLOS publishes papers from that field, sometimes they're a little kooky. Like they're, there was one that came out recently that's I'm sure well-meaning, but very shoddy science. Yeah. It was about like, I don't want to get too deep into it, but it was like something about like political affiliation and discourse structure. And they did a bunch of like cross-linguistic measures, but they only used the English language metrics for them, which, anyway, there were lots of problems with it. Feel free to go on Twitter and enjoy the drama there if that's something that you're particularly interested in. So PLOS, generally very good, sometimes a little bit funky, the papers, because it is a cross-disciplinary journal. So it can be hard for them to find reviewers. All right. So there, first of all, I like that all of my, all of the things are up here. Reader, ggplot2, dplyr, I don't think caret, maybe reshape. So many of these are in the tidyverse package. If you don't have a strong reason to import them individually, I would probably just import the tidyverse package and get rid of those, because it's a meta package and it's a little bit easier to do package management if you have fewer packages, which I had a nice long chat with Jake Vanderplas about today, because he is in package dependency hell right now. Anyway. So I like that. It's a little bit weird to do the pipe and then not have a new line after it. But I guess since these are, well, this would be something that a linter would catch, or your style guide for wherever you are writing the code for would probably provide you guidance on. Here, absolutely, I want all of this indented. Again, this is not a great, sorry, I'm focusing on the like the visuals of the code, and one of my coworkers was telling me that if you're focusing on visuals and things like style, it'll actually make you worse at doing the actual code review because you're not paying as much attention to what actually is happening in the semantics. So I'm going to try to ignore that. Okay, so we're doing an anti-join. So I guess we're doing a left join and then a right join. And then an outer join. And then we're R binding. So I don't know why we wouldn't just do a full join here, because we're adding all of these things together later. So I think there's probably a more efficient way to go about doing. Oh, I see. So the reason that they're doing it this way is because they're adding a new column data set that has this information in it. Is there a better way to do that? So there is in mutate. Oh, sorry, this is R as well. That just procced for me. I thought for sure the second one would be Python. We will do Python in the future. I'm probably also a better code reviewer for R than I am for Python, honestly, because I'm not super Pythonic. I'm working on it, but I'm not sort of good at like being like, oh, you can use a Python idiom here. It's an area of active growth for me. Let me put it that way. All right. So we might be able to use case win for this. Oh, excuse me. Ooh, goodness. Yeah, there might be a better way to do that. Because so joining operations tend to be fairly computationally expensive, and I don't know how big these data sets are, and if they're not that big, it probably doesn't matter that much. But especially doing 3 joins, I think we could do this with better time complexity, and I don't know how off the top of my head, but I've got that like I don't know, I'm like a hound with a scent, you know. I'm like, oh, there's something better. There's another better way to do this, and I don't know what it is off the top of my head. Okay, and then we're doing that to add the information, and then we're binding them all together, and then we are doing this. And I know I said I wouldn't do this. I also like this as I like different things that are mutated in the same row to be on different lines, just because it's a little bit easier for me to read. I am dyslexic, so it helps. Okay, so data set as factors. We're converting this string to a factor, so we can treat it as a categorical variable. That's something special about R and R data frames. We're converting DOI to character. Oh, I see, instead of numeric, because it is a number. Okay. And then we are changing this ID to numeric as well. So this is like changing phone numbers or zip codes to numeric, to characters rather than numeric, so that you don't like do something where you end up subtracting 2 zip codes from each other, which is, that's nonsense. That has no semantic value. So I think that's why they're doing that. And then they're selecting just those columns. And then they are removing all the values. And then they are getting rid of these 3 data sets to save memory. Yeah, and you do have to do that after you bind them together. I was like, can we create them and then immediately delete them? We cannot. All right. The final p-values dataset, all p contains millions of p-values from multiple fields. Oh, so it's big. Yeah, there's got to be something better than join. Yeah, okay, so I think what I would do is I think I would add to each dataset, I would add a column, because adding columns to datasets tends to be fairly fast. I would add a column that has this information, and then I would do a full join. And I believe, oh, you know what? No, yeah, I'd add a column to both of them. And then I would do a full join, and I would give the columns different names. And then I would, after doing my full join, I would do a mutate when to create a 3rd column that had either head 2015, Chevrolet Race 2016, or both, depending on the values in the previous 2 columns. And I'd probably actually just do 1 if it was from or true. True is numerically equal to 1 in R, because that's going to be a very, very small. It's not going to take up a lot of memory. And if there's millions of these, then we do need to worry a little bit about memory management. And then I'd add a new column where I mutated where, depending on, and I'd get rid of the other 2. I think is what I would do instead of the joining. And there's probably an R package out there for joining that has been made more, what's the thing I'm looking for? Efficient, has been like made a lot faster. And yeah, so, and one of the reasons I wouldn't do this is, so you can see that they've removed them, which is great. R allocates space for all objects in memory, like in RAM. So if you have a lot of big things that are copies of each other, it can make it harder to create new objects. Yeah, so that's what I do. And that way you'd end up with, so you've already read in the 2 data sets. So you'd have the 2 data sets that you read in, and then you'd have, with the additional columns, because that changes it in place, I believe, if there's available memory. And then you'd merge those into 1, and then you'd do this mutation and the additional mutation that's conditional. And then finally, you'd get rid of everything that you'd read in. And also for them, I would probably have removed the head 2015 and C 2016 if they don't need them again. So that's my... And again, I don't know what sort of box they're working on. The memory issues may not be a problem, but if they are, if this is something that they'd want to recreate later with a bigger thing, that might be helpful. Okay. So we want to restrict the analysis of relevant factors and the distribution of p-values to the analysis of omics fields in order to ensure accurate interpretability of the results. Okay, so we're subsetting the data set to only look at things that are genomics, transcriptomics, proteomics, and metabolomics, maybe. Anyway, so those things. And what we're doing is, so we're reading in the genomic CSV, we're selecting the ID, and then we are creating a new new column called field that has genomics in it. So it looks like we're reading in Entree UIT. So this is maybe something to do with the journal rather than the blah, blah, blah. It seems French. Okay. Oh, so it's a database identifier. So it's telling you, okay, so this must be a list of which databases contain which specific subfield information in them. And it looks like it's all medical information from the NCBI. Oh, from the National Library of Medicine. Oh, I was there last year. It's really pretty. It's like, it's kind of brutalist. It's got like that sort of like 70s office vibe, but then in the middle, there's like this enormous dome with this beautiful like sculpture. And anyway, it's nice. This is the US National Library of Medicine, I should say, because it turns out there's more than one thing that national can mean. All right, so we're doing this for all of these data sets that we're reading in. My gut instinct is that R-bind is not going to be super, well, no, because we're only R-binding once. So we're loading things in, we're futzing with them, and then we're R-binding them. What I would do is I would make a function that does this probably, just because we're doing it 5 times. So just like a little function that's like, you know, take in a CSV address and then say pass it what the factor is as the string, and that just makes it a little bit, you know, a little bit tighter. And if you wanted to add, you know, 18 more fields later on, then you could do that, and you just have to continue to call your beautiful function that you'd written. And then filtering the p-value data set to contain only articles related to the omics fields. So we're doing inner join again. And then we are doing a summary. So p-values, minimum of 0. Minimum of 0? Maybe it's, you know, 0.000001. It better be. You should not have a p-value of 0. And then a maximum of 1, basically. Okay, that's, I mean, it is in theory a value that ranges from 0 to 1, so that's not entirely unreasonable. And then we have a mean around 0.6. So, oh, and the third quintile is, sorry, quartile, not quintile. The third quartile, sorry, the third quartile, not quintile. The third quartile is 0.05, which at least in the social sciences is usually where we draw the line and say that things below this are significant and things above this aren't. The mean is 0.06. Okay, and then the median is 0.01. And what I know about medicine and medical fields is that in general, they have much lower thresholds for p-values because the consequences of messing up are much more dire. Like if I mess up a linguistics analysis, maybe we're like a little bit wrong about something and then somebody figures it out later. If you mess up a medical study and you tell people to take a drug and it turns out it doesn't help with the thing that they are taking it for, that's no good. That's downright bad, especially because it probably has side effects. And then we got the DOI. So remember that we converted this to a character, and then the database ID, which we also converted to a character. So we're not treating these as numeric, even though they are numbers. And then we have the data sets they're in. So it looks like the this one from 2016 was much bigger than the 2015 one. And then we have the distribution across fields. And then here we have a, it's really close to 0, huh? And here we have a histogram, so we can see the year, and it looks like the rate of publishing is going up, which makes sense with what I know about publishing and the number of peer review requests that I get. And then the p-values are highly skewed and clustered around 0. I think it might be a little bit easier to see if the bin size was a little bit higher. So I might go with maybe 100 or 1,000 for the bin size. Maybe 1,000 because we've got a lot of samples, so I'm not super worried about having a lot of empty bins. And I don't think the bin size for year super needs a lot of tuning, but I think this bin size could take some tuning. Okay. Oh, so this must be okay. It's an IPy notebook. It's a Jupyter notebook. So Ryan says, is p-value supposed to be above 1? No, it's not. Good call. Yeah, something must be. Oh, that's right. So there is some p-value that is reported presumably incorrectly or scanned incorrectly. So that does exist in the data set, but it should not exist in real life. So maybe that is a good thing for them to notice and figure out what that is. And just look at the next figure. I should call it a day because I got something else to get to tonight. You can see that there are densities. So this is 0.5 that I mentioned that a lot of social scientists will consider things to be significant at, and then right around 0.1 and 0.001 and 0.0001. So sort of the values tend to cluster around the thresholds that people tend to accept things as significant at. So one way we could think about this distribution is that if we're only looking at things that are sort of on this ridge, we can sort of draw the full distribution of studies that we're doing in theory that are null, and all the things that we look at that end up not being anything, and we're just seeing sort of like the little tail end of that. But then we wouldn't necessarily see such sharp spikes around the particular values that we're looking for. So. Yeah, I would love to keep coming. I am really enjoying this and learning a lot. Interesting. So here, the functions are being loaded from packages that are installed but not loaded into the session. And because so many other, and per and tidyr are both in tidyverse, so I would probably again, this would be a place where importing tidyverse as a meta package would save a little bit of typing. So I keep getting excited and seeing things. No, I'm done. I'm calling it a day. Thank you for joining me. I hope this was helpful. I don't want this to take the spot of the live coding in general, because I like doing the live coding and doing the coding myself, but also I think this is really helpful and I enjoyed it. And I'm learning some things, and hopefully you guys are as well. So yeah, I'll figure it out. Maybe like once a month, or maybe I do this in a different time slot or something like that. And just before I go, a couple announcements. Kaggle days. There's 2 of them coming up. There's one in Dubai. There's one in San Francisco. I think I mentioned this Wednesday as well. And on Monday, we're going to be dropping a video that I'm very excited about. It's another coffee chat where I interviewed somebody. And it's somebody who is not a Kaggler, but is very relevant to things that we've talked about on the channel before. So I'm going to leave you little hints. And that should come out Monday. Yeah. And if you're not yet in your weekend, have a good weekend. And if you are in your weekend, I guess continue to have a good weekend. I don't know. I'm tired. I got to get some dinner. Thanks for joining me. Bye.